Hello everyone, welcome back to my channel Learning Fundamentals by Ankit Shukla. I hope you are all doing well. Today we are going to learn about DHCP, how it works, its advantages. So without wasting any time, let's understand what is DHCP and how it is used in real world scenarios. DHCP, the full form is Dynamic Host Configuration Protocol. Imagine you are in a big hotel and every guest needs a room, but instead of choosing a room themselves, they go to the front desk where a kind hotel manager assigns them a room. This manager makes sure that each guest gets a unique room so that there is no confusion or overlap. In the world of computers, the guests are devices like your phone, laptop, tablet, and the rooms are the IP addresses. The manager who assigns these IP addresses to the guest, it is called as DHCP. So whenever a device wants to connect to a network, it asks the DHCP for an IP address, then DHCP checks which addresses are available and then hands them out to one of the devices. This way, every device on the network gets its unique IP address without having to worry about the conflicts. In short, DHCP is like a smart manager that automatically hands out the IP addresses to the devices on the network, ensuring that everything runs smoothly. This diagram best explains how DHCP manages IP addresses assignment in a network. Your home router is a perfect example of how DHCP functions. In case you remember the session 1 of the network fundamental series, we talked about private IP addresses. It had a router. This router works as a DHCP for devices connected to it. Let's understand how DHCP works behind the scenes. Picture a grand event where every guest needs a special badge to get into the party. But instead of each guest having to pick their own badge from a pile, there's a friendly concierge service, or maybe let's say your security at the entrance who handles this task for them. Here's how it works. First, the team greets the guest. This is called as discovery. When a guest arrives at the event, they don't have a badge. They approach the concierge, which is the DHCP server, and they say, I need a badge to get in. Then what happens is an offer, or you can say checking availability. The concierge service or the security looks at the list of available badges, uh, in short IP address is the background, and selects one. Then they say, I have a badge for you. This is DHCP server giving an offer to the client. Then the client confirms which badge to choose, right? It's like a request coming back from client to the server, and then it's like a request wherein client says, hey, I'll take this one. In the fourth stage, there is an acknowledgement from the security team. The concierge team hands over the badge and says, here you go, this badge is now yours, enjoy the party. In the network terms, this discovery, offer, request, acknowledgement is the sequential process starting from discovery, wherein the device sends out a broadcast message asking for an IP address. The offer, the DHCP server responds with an IP address offer. Then there comes a request. The device replies requesting the offered IP address. And then the acknowledgement. The DHCP server confirms the assignment and gives the IP address to the device. This process ensures that every device gets a unique IP address and can smoothly join the network without any hassle. Let's go a little deeper into this discovery, offer, request, and acknowledgement process, in short, DORA. This is the definition of DORA process. It's like a fundamental process, and it's a fundamental part of the DHCP that allows devices to automatically obtain IP addresses and other network configuration as well. If we scroll on to the next screen, we'll see that, or let's do one thing, let's break down each part of DORA process in detail. We'll start with discover. First step that happens in a DORA process is discover. Imagine you are in a huge conference in a massive hall filled with various booths or counters. You're looking for the information desk to get a map and a pass to access different areas of the conferences. You don't know where the information desk is, but you start by asking around. So here's what happens in the discover stage of DHCP. You enter the conference hall and you shout out, "Excuse me, I'm looking for the information desk." Your voice echoes, right? Your voice echoes through the hall, reaches everyone nearby who might know where the desk is located. This is like a broadcast signal being sent over the network or requested over a network. The information desk hasn't been identified yet, right? So your request is generic or general. You're basically saying, I need help finding out where I can get the pass, or in computer's term, an IP address to get into the conference room, which is the network. This request is sent out to anyone who might be able to help. This is the discover stage of DHCP. Your device, like the conference attendee, sends out a broadcast message to find a DHCP server, which is the information desk. It's the first step in the process, aiming to locate a server that can provide the necessary information, which is IP address, to connect to the network. Let's understand discover through a diagram. As you can see, when a client joins a network, it sends a broadcast signal to all the available DHCP servers, asking them for an IP address on the network, which can be assigned to them. Since this is a broadcast request, it goes to all the DHCP servers. Let's understand the next part of DORA process, which is offer. Let's return back to our conference scenario. After you've called out asking for the information desk, one of the staff members or multiple staff members from different booths, they hear your request and they approach you. They say, I heard you're looking for the information desk. We actually have an information desk here, and we can give you a pass to access the conference. This is the offer stage of DHCP. In this moment, the staff member from that specific booth or desk is like individual DHCP servers. They've heard your request, that is the discover. Now they are offering you a solution. They present you an available pass in digital world, the IP address that you can use to get into the conference room, which is the network. They let you know that this pass is available, and if you want in, it's ready for you. In technical terms, the DHCP server responds to the client who requested the discover packet or the discover broadcast message in the previous stage. They offer an IP address. This offer actually includes IP address and other configuration details that the device can use to join the network. It's the server's way of saying, here is an IP address I can give you. Do you want it? Let's understand this offer scenario through a diagram. As you can see, the DHCP server responds from right hand side over to this client, right? Now, the DHCP server responds to the client with an offer, which means, hey, I can offer you an IP address which is xyz.abc.def.ghi, right? I mean, in short, 192.168.0.1, whatever the IP address is, as an example. These are individual responses from different DHCP server, and hence this is a unicast process because they are responding directly to the client. It's a unicast process. Let's move on to the next stage of DORA process, which is request. Now, let's come back to the conference analogy, right? So you were offered a pass by one of the staff members from the booth or the desk. You look at the pass and then you respond, hey, I would like to use this pass to access the conference, please. In the DHCP world, this is called the request stage. Here's what's happening behind the scenes. So you have been presented with an option, that is the offer message in the offer stage, and now you're formally requesting to use that pass. This step is like telling the staff member, I want a specific pass that you have offered me. In technical terms, the device, which your request, sends a request message to the DHCP server in the third stage and indicates that it wants to use that specific IP address that was offered in the offer stage. This message is a confirmation from the client or the device that wants to accept the offered IP address and it is ready to proceed with it. Like, they want to use that specific IP address to join the network. Let's understand the stage as well through a schematic representation. Now, in this stage, you can clearly see that the client responds to one of the DHCP servers requesting to provide or assign the allocate the IP address which was offered by the DHCP server in the previous step. Let's move on to the last stage of DORA process, which is acknowledgement or simply acknowledge. Now let's wrap up our conference scenario. Now that you requested for the pass, the staff member nodded and said, got it. Uh, in the fourth stage, basically when you request on the third stage, the staff member responds that, okay, this is confirmed. This pass is now officially yours. Enjoy the conference. This is the acknowledged stage of DHCP. In this final stage, in technical terms, the staff member confirms that your request has been accepted and hands over the pass to you. They also make a note that this pass is assigned to you and nobody else can use it. This ensures that now you have everything you need to access the conference. Let's break it down into technical terms of DHCP. The DHCP server responds with an acknowledgement message to the device or the client. This message confirms the IP address that was requested by the client is now assigned to the client and provides any additional configuration details that may be required with that, right? The device is ready to use the IP address and connect to the network after that. Let's complete the acknowledgement process as well through a diagram. As you can see, the DHCP server from the right hand side confirms or acknowledges the assignment of the IP address that was requested by the client in the request stage, and this completes the DORA process. If you want to have a quick look in the entire detailed structure of step-by-step DORA process, this is how it is. The client requests for it sends a broadcast message once it joins the network. That request is a discover request, and that broadcast message is sent over to different DHCP servers in the network. One of the servers respond back, or multiple servers respond back with that offer to the client. The client then accepts the offer for one of the DHCP servers and requests a specific IP address that was offered by one of the DHCP servers in the request stage over here, and then the server finally acknowledges that the specific IP address has been assigned to it and the configuration details should there be any. In short, the summary of DORA process is explained over here: discover, offer, request, acknowledge, right? Now let's move on to understand the benefits or advantages of DORA process. It has multiple key benefits, like making network management more efficient and user friendly. Some of them are automated configurations. Uh, the device don't need manual configuration of IP addresses. The DORA process automatically automates this, and it reduces the human error as well and saves time, a lot of time. Efficient IP address allocation: by dynamically assigning IP address, the DORA process ensures that each device gets its own unique address, which avoids any conflict in the future, and it optimizes the use of available addresses. Then scalability: in large networks with many devices, the DORA process scales well. It allows a network to handle a growing number of devices without requiring extensive manual configuration. Then another Key benefit is flexibility. Devices can join and leave the network seamlessly. When a device leaves, its IP address can be reassigned to another device, and it makes the network adaptable to changing conditions or variable conditions. Centralized management, reduced network configuration errors, efficient IP address reuse. DHCPs can reclaim IP addresses from devices that leave the network, which makes efficient use of available IP address space and reduces the risk of IP address shortages. Overall, the DORA process streamlines the network management, enhances flexibility, and improves the efficiency of the IP address allocation, which leads to a more reliable and easier to manage network. Now that we have understood DORA process, its advantages, and how IP is assigned by the DHCP server, let's also understand the IP renewal process. IP assignment is a temporary as well as a permanent process in a network. There are three processes in IP renewal process or IP renewal cycle. First one is a renewal request. When a device IP lease is nearing expiration, it sends a renewal request to the DHCP server asking to extend the lease on its current IP address. Then a renewal offer is made by the DHCP server, which indicates that the lease can be extended and then the device can continue using its current IP address. Basis that, a renewal acknowledgement happens on the next stage, which means that the DHCP server sends a renewal acknowledgement message, officially extending the lease and confirming that the IP address is still valid for the device. This process ensures that the devices can keep their IP addresses without interruption, allowing them to stay connected to the network seamlessly. Let's understand this IP renewal process in detail. As we have read that there are multiple stages of IP renewal process, the IP renewal process actually helps maintain uninterrupted network access by extending the lease of current IP addresses, by also reducing the need for frequent reconfiguration and ensuring that the network connections remain stable. Let's move to the penultimate section of today's session on DHCP, which is static IP and lease policy in DHCP. DHCP static IP, it's often called as DHCP reservation or static lease. It combines the benefits of dynamic IP allocation with the stability of a static IP address. Here's a detailed explanation of it. Uh, there are two types of IP allocation in the DHCP. One is dynamic IP, one is static IP. We've already studied about it in the first chapter of network fundamentals. DHCP static IP is a method where you reserve a specific IP address for a device using DHCP, ensuring that the device always receives the same IP address each time it connects to the network. So let's say a device, you switch off, there is a user who leaves the company or maybe on a long leave, and their device is not connected to your company's network for a long time. Um, should they have this static lease process, or let's say static IP assigned to their machine? What will happen is, even if their lease period expires and once they rejoin after a couple of days, their laptop or desktop or whatever device they have, it is connected back to the network, it will again receive the same IP because of static IP assignment to that device by the DHCP server. Now, for static IP assignment or lease, there is a DHCP lease policy which refers to the rules and configurations that govern how IP addresses are allocated and managed within a network using the DHCP process. DHCP lease policy determines how long a DHCP server will assign an IP address to a device on a network. Let's understand through a simplified explanation. There are, and these are in sequential order, right? The first one is IP address assignment. So when a device like a computer or a smartphone connects to a network, it requests for the IP address from the DHCP server. Then there is a lease duration, like the DHCP server assigns an IP address using the DORA process to the device for a specific period. This period is called as lease time. This is defined in the lease policy. Third stage, you have renewal. Um, Before the lease of the IP, which was assigned by DHCP server to the device, it expires. Before it expires, the device will try to renew the lease. It sends a request to the DHCP server to extend the lease. If the server agrees, it updates the lease duration. Let's say, and again, there can be a possibility that the server does not entertain that request, will not go that deep, but will understand the next step, which is expiration. Let's say if the lease expires for the IP address of a device that was assigned by the DHCP server, and let's say the device did not renew it, the IP address is then returned to the pool of available addresses with the DHCP. Then the device will also have to request for a new IP address. They will not get the same address. Then in the DHCP lease policy can be configured to provide either dynamic leases, which means it changes over time, or static leases, wherein specific devices always get the same IP address. And it is also part of the lease information. Now, DHCP lease policy offers multiple, or you can say several advantages for managing network IP addresses. Efficient IP address utilization, like DHCP dynamically assigns the IP addresses, so it ensures that the IP addresses are used only when needed and returned to the pool when no longer in use. This helps in managing limited number of IP addresses more effectively in a small environment. Simplified network management, it automates DHCP automates the IP address assignment, which reduces the need for manual configuration and minimizing the errors. This makes network management easier and less prone to mistakes. Centralized control, administrators can configure lease policies centrally from the DHCP servers, allowing for consistent management across the network. Reduced configuration overhead, devices automatically receive their network settings like IP address, subnet mask, gateway, DNS servers, etc. from the DHCP servers, and it saves time and effort compared to manual configuration. Flexibility in IP allocation, the lease policy can be adjusted to fit different network needs, such as shorter lease times for the guest networks or longer leases for critical devices. Easier network changes, when network changes are needed, such as adjusting the IP addresses ranges or adding new devices, DHCPs can handle these changes smoothly without requiring manual reconfiguration for each device. Now it also supports for it also has supports for the mobile devices that frequently join and leave the network, such as laptops or smartphones. um, benefit of automatic IP address assignment is there, and then it ensures seamless connectivity as well. DHCP also help in improved security. The dynamic IP assignment can enhance security by making it harder for unauthorized users to predict or use static IP addresses. In summary, the DHCP lease policy streamlines the IP address management and improves the network efficiency and reduces manual or human administrative overhead. All right, folks, this is the end of chapter 4. I'm sorry, chapter 5, wherein we have learned about different DHCP servers. DHCP, DORA process, its advantages, and etc. We've got plenty more videos on IT and Microsoft 365. This was the end of our network fundamental series. We have 5 chapters. In case you're watching it now or in future, make sure to start the playlist from the beginning, from chapter 1, chapter 2, 3, 4, and this is the 5th one. You can check them out to keep learning and stay ahead in your technical game. Thanks again for watching. This is me, Ankit Shukla, signing off, and I'll see you in the next video. Take care and have a great day. Take care. Bye bye.